Hello friends, welcome to the next video of this series. Today we will talk about some of the deployment option of the Kubernetes clusters, and we will also talk about one of the popular option which people use during early phases of learning Kubernetes deployment, which is MiniKube. And we will try to create our first cluster today, and we will go through some of the components that we just discussed in the last video, where they are, how they are running, how they are interacting with each other. So we'll try to explore those things today. Okay, so what are the options we have in terms of deploying Kubernetes? When I say options, so we talk about basically two nodes on the Kubernetes cluster. One is worker node, one is control plane nodes. Okay, and then we talked about there are certain components of the Kubernetes environment which makes up Kubernetes, and some of them are control plane components, things like API server, scheduler, controller, um, etcd, and then we have kubelet, kube proxy, which is running also on the control plane as well as on the worker nodes. So we can put all of them on a single node and run them together. That is one option. The second option could be that we will have single control plane node and we will have multiple worker nodes. The control plane would run your API server, scheduler, controller, and this key value store, which is etcd. And on along with it, it will have kubelets and the kube proxy that has to be everywhere. But then each of the worker node will have the user's pods or applications, or along with that, they would have this kubelets and kube proxy. Third option could be we will have a single control plane with single node etcd and multi-worker installation. This case is talking about the case where we will have again single control plane. etcd is also single etcd, but it is running maybe on a separate node. And then we have multiple workers. And finally, we can have multiple control plane and multiple worker nodes installation, which is the fourth option is most common installation in the cloud environment in a deployment of a reasonable scale, whereas the first option is only used for the learning process, not much use case, because when you talk about it, you're putting everything in the one single node. That node goes down, your cluster will go down. You don't want that. You want high availability cases. So generally what you do, you have multiple control plane. On top of that, you would have etcd also on a separate node and sometimes the multiple instances of etcd as well. And then you have multiple workers. So if let's say one of your control plane node goes down, the entire cluster will not go down because there will be other control plane nodes that will take over and that will take care of the cluster. Similarly, if you have multiple etcd, even if one of the etcd goes down, your key value store goes down, the cluster will still be working properly because there are backup etcd which can take up the loads and work from there. So the real configuration for any production grade Kubernetes deployment would be to have multiple control plane nodes, multiple etcd deployments in a separate node, and then you would have multiple worker nodes. Okay. So that's what we talked about: multiple control plane, multi-node etcd, and the multi-worker sessions. Okay. So how do we deploy this? So you talk. One way is doing it everything manually, right? You would have your configuration files. You will deploy um, all of this application manually one by one. API server, scheduler, controller, kubelets, proxy, everything. But generally, we don't have to do that much work ourselves. There are lots of tools available which allows us to install these applications or agent or processes which are used for building the Kubernetes as it is. Um, so MiniKube is one very popular option. It is used for the single node or multi-node local Kubernetes cluster. Generally, it is recommended for the learning purposes. Kind is again a multi-node Kubernetes cluster deployment option. It is mostly used with Docker only. Then we have Docker desktop. It is again used for local Kubernetes cluster for Docker users. Now we have micro Kubernetes and K3s. These are two options generally people use for cloud deployment as well as local deployment, but generally for the production reasons. So this is the one where we have a bigger scale, basically, larger scale deployment with micro Kubernetes and K3s. Today, we will talk about, or we will have a quick demo of the MiniKube installation, and then we will try to create our first sample cluster with MiniKube, and we will go from there. Hey friends, so we will start installing MiniKube. To install MiniKube, first you will have to download it. On Mac, you can do it with this command, and uh, this command should download it for you. Let me remove this special character from here. Once you execute, it will download MiniKube for you, and when this has been downloaded, you can simply install it with the name of the package sudo d package -i install name of the package, which is this one. This is all you have to do. It will install MiniKube for you. I am not going to do it because MiniKube for me is already installed. Fine. So once it is installed, you can see if there is any cluster that you have already available. No, right now there is no cluster is running. Okay, to create your first cluster, you can execute this command minikube start, and this creates a default cluster with one single node in it. With the driver, default driver is also high. It will pick up your default driver based on what you have on your system. By driver, I mean the virtual environment that you have installed. If you have VirtualBox installed on your system, it will pick up VirtualBox. If you have something like HyperKit installed, it will pick up HyperKit. And if you have Docker installed, it will pick up Docker, etc. So depending on what kind of virtual environment is available on your setup, it will pick up that as a default. And then also it will try to install or create a cluster with one single node there. It will take few seconds, and I will see that very soon I will find that my cluster is ready. Once my cluster is ready, the next thing I would do, I will install one utility called kubectl, which is used to poke around with my cluster and do any stuff inside the cluster. On Mac, installing kubectl is very easy. So all we have to do is brew, install, brew, update. I have to do first, and then brew, install kubectl. That's all I have to do. Again, I'm not going to execute this command on this system because this is already done. So now I am ready. I have installed kubectl, I have installed MiniKube, and I have started MiniKube, which means I have one default cluster available. What is inside my cluster? Let's see. MiniKube status. It says one cluster is running. Okay. If I say kubectl get nodes, how many nodes are running? It says only one node is running. Okay, there is nothing in the default namespace. We are perfectly set up. Okay, fine. So what we have installed MiniKube. We have installed kubectl. When we started MiniKube, it created one default cluster. The cluster had one node only. Driver it used was HyperKit. Okay, and there is nothing running inside this system in the default namespace, but there is another namespace. -n means namespace, and let's see what are the things, what are the pods running in the Kube system namespace. You have to remember what is Kube system. Kube system is the namespace used by the internal processes of the Kubernetes, not the user process, but the internal pods. So here we would see our API server, our controller, our proxy, our scheduler. So these things we have discussed in the last videos, right? So if you bring up any cluster, you will have API server, you will have your controller manager, you will have your scheduler, you will have your kube proxy, you will have your storage provisioner, etcd service. So we can see core DNS. So all of these services get installed by default for you by MiniKube, right? So it makes your life very easy. Now, let's say you want to install or create one pod this um, inside this cluster that you have created. How do you do that? The simple thing you can do is kubectl create deployment. So create deployment is a command that you would use to create any new pod. And then you give the name of the pod. Let's say I call it sample dpl. Only argument I would give is name of the image. There are not many argument it can take. And let's so it is going to create a deployment. It means it is going to create a pod using image nginx, and we see what happens next. What created? What is the status of this pod? What is this doing right now? We can see it using command kubectl get pods. Okay, my pod is running for 30 seconds. Remember, the first time when we executed kubectl get pod, it gave us nothing because in the default namespace there was nothing running. We just created our one pod. So it gives us the name of the pod. It says the status is container creating. We type again. Now it says running. Fine. So we have created one pod, our first pod in our first default cluster, and with the name sample deployment. If I want to poke more around it, we can say kubectl describe pod and then pod name. It would give much more detail about this pod. Hopefully. Okay. So what are the things we see? This is the command we executed. As a result, we are getting the name of the pod. It is running a default namespace with priority 0. It says what was the start time. It says what is the pod IP. Pod IP we discussed, right? Any pod which you start, Kubernetes will give it a internal IP. Now using this IP, this pod can be reached from the within the system basically. Okay, and then it says what is the image it used. We started with the nginx image. What was the image ID? And there are so many other things for the certificates and etc. So this is how you can describe your pod. This gives you much more information about the things that this pod is running. If you want to see the logs of this pod, we can call kubectl get kubectl logs. Name of the pod again. And not much log coming, but we can still see some of the things which is coming up inside it. So we will experiment with kubectl much more in detail, but this video is more about MiniKube. So we created one simple cluster with one single node. What if you want to create multiple nodes? What if you want to change the driver type? What if you want to change the container native interface? Networking interface, sorry. We talked about that, right? So Kubernetes itself does not have its own um, networking manager. What it does, basically, that it provides standard interfaces using which any vendor can implement networking for Kubernetes. For example, You can build your networking based on Linux bridges. You can build it based on Mac VLAN, or it could be anything else, right? So it depends how you want to implement your networking. Kubernetes proposes standard interfaces for that. So if we want to, let's say, for example, create another cluster, we want to create another cluster, and this time I'm using the driver as HyperCade using 3 nodes. Container runtime, I'm using container D. Container networking interface, I'm using Calico. I'm calling this container as, let's call it mini box 3. Okay. Let's see what happens. It is creating it now. And this time we are creating it with 3 nodes, so it is going to take a little bit more time. Let's wait for a few seconds. If we have a given number of nodes at 3, this should create for us 2 worker nodes. Okay. Now it is starting the second worker node. By default, it is taking 2 CPUs and 2700 MB of memory. You can always modify and change it to something different. Okay, so my next cluster, or my second cluster with 3 nodes, has been created. We have 1 control plane node and 2 user plane or worker node over here. Let's see what MiniKube says now. MiniKube data, and it is still pointing to the old thing. So MiniKube profile is the command which you would use to list down all the cluster which are running. It says it has got 3 cluster running right now, one with the MiniKube with the runtime as Docker, and then there are one with the runtime container D. We just created MiniKube 3, so I would point my MiniKube cluster to this one, MiniKube profile, MiniKube 3. This command should point MiniKube cluster to the MiniKube utility to the MiniKube 3 cluster. Uh, Sorry, it was not MiniKube. Its name is MiniBox3. Done. So now if I do MiniKube status, it's going to show me the status of all the nodes. And if I do kubectl get nodes, it will going to show me 3 nodes. Kubectl get nodes. And if I see any pod running here, kubectl get pods, nothing. See, when I switched profile for MiniKube, kubectl got auto modified. Okay. Again, we can do the same thing over here. We can install or create a. Before we do that, let's see what are the pods running in the kube name system namespace. Kubectl get pods minus n cube system, and we would expect a little bit different this time, right? Because the nodes are running, so we would expect more than one kube proxy running, which is the case. So we see there are 3 kube proxy running, each one for each node. We have one API server, we have one controller, one etcd service, and then we see code DNS is running. There is a Calico networking CNI interface which is running on each node. Okay, and then we have a scheduler and provisioner. So these are the processes running, or these are the pods running in the worker nodes and the control plane node in the kube system namespace. But there is nothing in the default namespace. There is no user process or user pod is running. If we want to go and see what is there inside, or we want to expect a little bit more, one of these pod, let's say the Calico one, the kubectl describe. So you see, it's not able to find out that it is because it is inside kube system namespace. What happened? Oh, describe pod. Yep, fine. So we can see it has got much more detail, and here you would find the node IP. Exactly that. Yep. Call up. Yep. So here we see the IP of this port, name of the port, what image it is using, the version of the image, and the status. They say that completed. Most likely the purpose of this CNI interface was to give the IP to the interface and then exit. And that's what it did. And then there are some other parameters related to which are specific to this plugin or pod. So this is how we can create our sample cluster using MiniKube with one node or multiple node. We can walk around node. We can see much more detail inside node, or which can see what are the pods running in the default namespace of Kubernetes. We can see what are the pods running in the system namespace of Kubernetes, which is kube system, and we can play around it. I will add some of the commands in my GitHub page so that you can directly access it and play around with it. And also I will give you a link to the GitHub page with this video in the comment section. Thank you.